So I do have this, yeah, the PDF for that I'm gonna pull up. Where, yeah, so I'll just take some overalls and get my projection plane built. So what, 70 wide by 35 tall overall, that looks correct. For front view, and 70 by 35, and then the depth is going to be 60. It's a pretty simple box to build. Good. I'll open my template file for. I'll just open my ASME ISU B, or sorry, A3 size sheet. Yes, A3 size only. That one. That's what I'm going to use. Let's see. So let's build this box for this thing to live in. Zoom in a little bit. 70 wide, 35 tall. That's right. A few inches away or something. Let's see. 70 wide again. By 60 deep on that. Do a miter line here. .45. Let's build a right side view. This is, I do remember this is the shape I had to draw as an instructor. Like you'll find, like if you ever take sometimes like applied instructor jobs, they'll actually give you an assignment. Like I had to come in and draw this myself. That was part of the interview process. I remember this was the part I had to draw. And yeah, I don't know what they do for like automotive and diesel. For welding instructors, they just give you weld tests actually, just like you would in industry. So CAD tests, a lot of times if you're interviewing for CAD jobs, it could just be they just give you a CAD drawing to draw. And they may give you some resources that you have to like research and do a little bit of research. They they give you a floor plan. Yeah, yeah. So it can be kind of challenging, it can be kind of nerve wracking. It might be a time drawing. I think I had 60 minutes to get this thing done and ready to plot and print. So yeah, they can be kind of nerve wracking tests. Surprisingly, when I went out to the site to draft, they didn't give me any kind of drafting. In fact, I told them in the interview I wasn't even that kind of a drafter. They still had it. So they were desperate. And I found out they were. So they were desperate. They just had a hard time finding some of the INL positions out there. They're not real clear on where to even go looking for the jobs, right? Like Department of Labor, that's why the Department of Labor is kind of a good resource, because some of the more inconspicuous job postings can show, if it's in the state of Idaho, will show up with the Department of Labor. So I've learned that is a great place to just check like mass listings, and at least within the state. But because yeah, they're just, some places don't, they might use Indeed, or they might just only be on their website or other Handshake or whatever. But it's like hard to find all the job postings that might be available. And the Department of Labor, I have found, is probably the best as far as blanket. And then every state's Department of Labor is a good thing to look into, actually, if you're looking out of state. Something that, but I'm going to draw now. Let's see, front view. I'll start with my front view drawing. I've got my projection built. So what front view? Oh yeah, I'm gonna take this over to my other screen, but I'm just gonna draw this in what I can tell, and come back to this little detail here. I'm just gonna draw what is really on my surface. This is generally how I approach these two. Is I'm gonna draw what is clearly obviously on my surface, and then the stuff that's like off my projection surface, I'll come back and try to piece that together. But looks like it's 50 millimeters over to where this little potential, where I might pick up this line in my view here. So, okay. Move that over. Let's get rid of those math. So I'll just trace around what I know. The I'm gonna start. It kind of starts at the very top surface right here. So I feel like this is a good for me. This is a good way to interpret the measurements. It comes down 35. No, it comes down 30 is what I get if I do some math. Then it comes over. We're gonna watch this a little bit. 20, 20, 40, 60, 5, 5. Comes over 25, I think, right here.
Wait, how tall is that construction box?
Oh man, I'm way too. I gotta turn on my floor tracking on the right. Well, mine I have it as overall is 35 is what I got. Yeah, 35 is the overall height of this. Yeah, yeah, 35. I gotta make sure my tracking is on. I don't know why I was off. I actually have my tracking on. I just pulled it off slightly, so it's 30 coming down this side. I started here because everything. I don't know. I need to go. I mean, you could start this anywhere for sure. I'm gonna come over 25, down 5, over 20, up 5, back over to this side. And from here, I'm only up 15, looks like. And then back over 60. I'll see this line all the way across. I have 60. And then it's going to go up to the top, across the top. It's definitely the surface where my eyeballs are on in the front view. Yeah. And then over 50 and down to that same. So I feel like I'm going to have one more. From here, it would be over 50, I think. Not that direction though. What is this measure? And I'll just add to it. This measures, it was only 10 there. Does that make sense? Yeah, it's 10. So over 40 from there is what I'll say. From that point, that's 10 millimeters. The real thing goes over here, 50 millimeters. This is where this should look and come down. And this is a foreshortened surface in my front view for sure. It starts here. Technically, it's like got some depth away from me at this line, and then this is all foreshortened where it hits that. So this is minus the and I think I'll put the counter bore in the top view and then project it down. I think I'm gonna just go with these surface features here. Technically, I've got a little something going on here. If you could tell there, this is the trick to this, and this is the real inconspicuous part of this is that this little notch here is affected by this however this miter's down, whatever degree that is, the difference of 35 to 26, or really the difference of 30 to I think 26 is off the very bottom. I think I tried to show that with a little just to show that 26 is from the very bottom surface up 26. And I've got this mitered slope here, which then impacts this mitered slope here. And this is what this little section right here is what makes this kind of a weird drawing, actually. The way those intersect each other is strange. And I'm not going to get, but what I would see that I'm not showing right now is like in what I've drawn so far is I've got this as a totally rectangular surface that is foreshortened, but technically it's going to hit this point and then drop off a little bit. So maybe I'll wait on that. I don't know if I have, I don't really have that dimension. I don't have that linear length either, like given on this drawing. I'm hoping this is going to maybe fall together with, I don't know, between rights and tops. Like what I'm doing is I'm just keeping this as like a real, and ambiguous what's going on here. Maybe and I'm going to move to my other views and just see if this will fall together and be able to project across. I don't know. I feel like my right side view is going to help inform some of that potentially. So I'm just going to proceed. But what in my mind, what I'm telling myself is that there's something going on here that I can't quite figure out. So I'll just leave this. All the other points I'm going to project up though. So I'm gonna want, and I'll just take some of these points all the way across. And but I definitely have that point. Definitely have this point. I can take these bottom points across too. That's the bottom. then I just gotta make sense out of them up above, but that's kind of the main feature points that I projected over. Okay, cool. And then I'll start sketching some of it in the top. So I'm gonna look at my top. Full over, back over, that's 10. Do we give, oh yeah, this is giving it 35 millimeters to this little spot here. Okay. And I can draw that in later. I'll just do the overall outline first, I think. Okay, let's see. I have that up on my other screen. If I pull it over again.
For the box on the front seal, what did you, what is the link? Like on the, kind of, I don't even know.
Which one here in this area here?
I don't know.
Like right here?
Yeah.
Or even this one?
The other one.
This one? Yeah, how do I get this? This one I got with this dimension. It's like let me see here. Oh yeah, it's this 50 millimeters. So I came over like 50. I already had this kind of drawn in, which is 10 millimeter. That's 60 minus 70. Yeah, so that's 10 millimeter. So once I had kind of drawn this shape in first, right? And then I just came over from that point and drew over the remainder, which is 40 millimeters over. That's how I knew where that point was. At least that's how I know where this technically this edge is. I really don't know where that point is or that point is what I'm kind of, but yeah, I know where this edge is. It's 50 millimeter over from the right side surface. Yeah. And then I know the depth of this because of the way I drew this, but it's going to be, this is 20 overall off the base. It's 5 millimeter plus 15 is 20. And then this, so really this dimension should measure 15, right? 15. I'm going to check that myself. Sure. This should measure 15 if I drew it right. That looks right. And then this one I definitely pulled off of is 50 overall. With the foreshortened distance only being 40 millimeters, if I'm totally looking on it here, perpendicular. Yeah. Good. Now I'm back to top view here. Top view is there. I think the whole footprint I'm going to see like this. All the surfaces, even though they change, I'm going to see them as a total square. Square. Let's see, and then in the top view, I'm going to come over this far. That's 15, so that's like a 10 and 15 over. Then it's going to angle over that way. I'm also going to have a line that's 35 millimeters over. So I'm going to see both of these lines. That's it, though. And then these are going to be hidden underneath. So really, this surface isn't going to look too. I'll come back to the hidden lines. Maybe I'll try to get in the visible lines on top. So I feel like I need to know 50. I need to know 35 and 15. So let me come back. I think the way I see this is my 10. Yep, this is 10 millimeter. It goes 15 is what I think. And then this angles over to somewhere here, but I don't know where, so maybe I'll stop there. I don't know how far that comes over. I also have a line that's yeah, I said 15, and then at 35, it comes over some unknown distance. I don't know how to terminate that, but I know that this, from this point up, 35 millimeters, this line comes across, and I'm going to pull it through everything. It ends out here somewhere. I don't know where. I'm going to go here to there, potentially. I'm going to come back. I'm going to go look at this side, what's going on here and there. Really, that's 38. I got a weird dimension here. I got a dimension here. I got like 38 millimeters where that's going to end. So I think that's what I think. I want to know that. I might draw that with construction. This is going to be 38 over and kind of 50 over here, and where those meet is going to be this point. So I think I'm going to identify this point, and let's do that. So 38 is what I said. I'm going to do this on construction later because what I'm going to do is I'm going to cursor up here like 38. And over here, this goes clear over to this point here. So I feel like this is weird, potentially. That's definitely where I'm picking up this edge here. Then it goes back over to here. That might show. And I remember I drew this long. I drew it out past this just to help myself remember that I haven't determined the length of that yet. I think this, when I look straight down on that, should go from 15 millimeters up, and then it should go across and hit that point like that. Then that should go back into the back side. That is going to identify that point right there. So this dimension wasn't given, but this is something that I was able to figure out from point to point, just looking at the dimension. So I'm able to trim this now. This is going to be trimmed. I end up with something like that. So at this point across, that's actually where this, this surface is foreshortened to me now. It's like sloping down away from me. This surface is perpendicular to my eye. My eyeballs are right on this surface here. So this is all kind of true length stuff, except for then it hits there, and this is not true length from here. Well, actually, it's right here. It's not true length from there down to there. So I have to keep track of this. This is really close proximity to each other. Remember, this line is actually probably a hidden line underneath. Yeah, it has nothing to do with what's going on top. So I don't want to get those two mixed up. They're close in proximity. They're close together. So I gotta project that down. I think if I project this down to here, that's where the slope starts back to here. If I knew the height, that is. If I knew, so I'm gonna look at my drawing. Let's see. Do I know this height? It's really not given to me. I think the right side view is gonna help me determine what this height is gonna look like. For sure, I'm able to at least pick out this point from top down to front. I've definitely locked myself in here. Just haven't quite locked myself in here. So I'm going to try to keep track of this while I'm thinking about it and say I'm going to project another real close line. This is information the front view could use right there. And down here to where that foreshortened surface, oh man, it's so close, it's going to be easy to mess up. That's why I also took this one next week. Right there. So at this point, what's going on is something that I've just got a point, but what's going to happen is this is going to like come down here and like intersect here somehow. I just don't know what that height is. And that's going to look more correctly like that foreshortened shape. I'm not going to put this in yet. I just want to show you this is where I'm looking to trim that out to kind of show that it's a little bit of a compound problem here. But so I'm going to come back. I think it's going to come over from the right side and help me lock in the height. Is what I can see. It's definitely a height dimension. The only place I'm going to get height is front or right side. I think I'm going to be able to project that around to the right side view and then back across. So it's going to be information that's going to come full circle. Okay, projection. Oh man, I love projection. So it helps solve things that I can't solve mathematically or yeah. The information's there, but sometimes I just have to start drawing and figure it out. But this is what it would look like in top. I feel like I've kind of locked in the details from top down. I know this is a weird foreshortened length, but anyway. So I'll put in my my counterbore stuff here, right? So let me just look at the location for that. It looks like it's coming over from this point, 35 over, 15 up. Then I've got a 10 millimeter through and a 20 millimeter counterbore at 5 millimeters deep. Okay, so let's do that. 35 and 15. I'm looking for a center point here, so I'm just going to go back over here at 35 and then up 15. That's where the center of that will be. And if the counterbore is 20, that's also something to watch here. Oh, it looks like that pretty well. The counterbore lines up with about the same width across here. That's a 20 millimeter. I'm just interested to know this is 20 across. Those are technically lined up. And then it's got a 10 millimeter through smaller bore, which I'm drawing by radius, that's fine. That's what it looks like. So I don't really need to project down, what I'm noticing is I don't need to project down new material to figure out the outer counter bore. It's already kind of in line with that. It's gonna be 5 millimeters deep, so pretty shallow maybe. But I am gonna project down the inner bore that I don't have yet. So I'm not gonna move on yet, maybe till I just define a little bit more. There, and then this one goes all the way through, right? Yeah, so these are my through hole. There and there. Then while I'm thinking about that counter bore, it's going to be from this surface down, right? This is that surface. And so it goes down, maybe I'll just cursor down 5 millimeter and come across. I'm going to retrace that with hidden line. I'm going to work over to my hidden line work and work both of these views with a little bit of hidden line detail. I'll do this one first. So this is the counter bore from there to there to there to there. And then I'm going to do the through. Oh, and I'm not projecting your screens. You guys want me to throw over to your screens? Nobody's complained yet, but I can. Let's see. Forget that I didn't send that over there. Perfect. So you can throw me out of the way there. But now this is what I'm looking at now, is that I've got hidden line work. I think there is some more hidden line work that I will project over from right side, because technically I could probably figure out what it is, but what I'm thinking is this top surface then slopes down and away from me in the front, like this surface here, top view surface is kind of down and away from me. I'd pick up this line as a hidden line over here, and it's probably like I probably have the information I need. It's this, right? It's that 26 millimeters up from the very bottom, and it goes across 50 millimeters. So I could put that in. I really don't need to project it from the right side. I will. So I think I can go ahead and come back while I'm thinking of hidden lines and say it's 20. Is it 26? So weird. Yeah, 26 millimeters up. So I think that I'm going to just put that in while I'm here. And I'm on my hidden line layer, so I might just do it with the hidden line layer, but it's 26 millimeters. Then that's where that comes across until it hits here, right? So that's the back edge surface where, that's sloping down away from the top down. More of a slope than I think. It's quite a bit of an elevation draw. So that's definitely way foreshortened. And the reason why I'll keep drawing for sure is that I'm like, well, I've got the details of it, kind of how it looks in the front view, but I know it's foreshortened in the top view. So I haven't really defined its true length yet. So I'll definitely need a right side view to see if some of that exposes itself and the true lengths are, so I can dimension this surface. I don't have a way to truly dimension, especially from here down yet. This is foreshortened distance. This is all true length here, here, here. But now let's finish. I'm going to finish some these in the top view. I want to put them in right here. I got to make sure I don't get the wrong one. It's the outside line here. Is where the comes across as a hidden line. I'll do the next one over, which is this one. Pick up. Yeah. I think that's about all I can do right now. Is there anything else? That one put in. Got center lines to put in when I come back. I think I'm ready to project stuff over to the right side view. Take a look here. Yeah, that looks good. Let's do it. I think I'll bring the whole over last for sure. I think I'll just bring over and this is pretty normal. I focus on, I always feel those are like features of size or features, on within the part. And I like to always just project over what's mostly going to be visible line work or the main object features is what I think of when I start projecting. And then I come back and do, particular features secondary is just how my method is. But So I definitely gonna need to, so I'm just gonna bring over all these point to points. This point is gonna come over. I'm gonna make a mess here, but I'll have to keep track of it. At that point, this point should come over. Help me figure that out. This point should come over. And this is gonna come over later, but, and then I also wanna pull this one over, I think. Oh, I've already got it. It lines up with that. So I don't necessarily need to pull this any more data over. I'm already pulling it over from here. So, and then I'll come back to this. So I feel like I'm gonna sketch in what it looks like and maybe take a quick look. Looks like it's gonna look like a solid line all the way down. This front surface edge. Even though this is offset this way, I'll see the whole bottom line all the way across that 60 millimeter. And then from there up, I'll see the full thing up because even though this is offset from it, I will see those edges. So really, it'll be up 26 and then over up to where it meets the top. So I'm going to put that, yeah, this is maybe a little bit of a simpler side to draw in, and 35. So it's going to be, to me, this point to point. I already have it. I should have it just to connect over here. From here, I'm gonna stop right there. That's where that should be. That should be what this distance here is 35. That sounds correct. 35. Yep, 35. Then down to 26, so I can come over from there and up 26. I could have projected maybe some of them. This is where this comes into there. There's a true length. At least on the right side surface true length. It's more complicated over here still, but yeah. We'll project over some front view material. This one I need to know across. This one I'll probably need to know across. It'll be hidden from me though. It's definitely a hidden surface. I'll need to know the depth of the counterbore. I'll need to know maybe over here. I should see that too. And the width of the counterbore. Maybe I'll work this stuff first, then I'll come back to the counterbore from the front over. Let's see. Well, that's offset back 25 millimeters. I'll still see the full visible line all the way across. See that surface, then this will come up. Over, come across. So I'll see this surface as a hidden. I think what I'm looking at here is that I'll see, to me, I'll see this surface as a hidden line all the way across. I'm going to see some vertical lines hidden down, probably like this one for sure. I think I projected that point all the way over, but I'm gonna draw it down at least to that surface. So this hidden line is this surface here. So I want to see that line. And I want to see this line as well. I'll make sure that I've got that one projecting over and down. So it should have two little vertical lines here that show that. I think I have them just place them here. This edge here will be from top to that other surface like that. This edge here is a little bit unknown. It's that's the other key piece that I'm looking for, is right there. So if I follow this, or if I follow this over, for sure I should see this edge as a vertical line that's hidden in my right side view. I'm just gonna follow it over and see it's actually gonna pick up right here and then down to here. So this was a critical dimension I didn't have. I wasn't giving it, but it fell together in my right side view. So now I can take that information back to this view here, and then I know where to connect these two at then now. So what I'm saying is, while this is on my radar, I'm gonna say that was key information I needed, where this edge comes across to there. And what we have going on, I'm gonna turn this off just for a minute so I can kind of see what I'm gonna do here. Turn it off. I'm gonna go to my visible line work. Oh, sorry, I need to keep it off just a second. It's got the one piece of data. Never mind, I keep it on. It's got this one coming down. There's the two that I need to connect with visible line. So it goes from here to here. And then if I turn this off real quick, I'll trim that out. This gone. However, that's a foreshortened length here. It's like it's kind of this whole surface is going away from me here, and then it hits that point, then my surface continues to from this point to this point in my view here, it continues to go away from me. So this is foreshortened, almost like a compound foreshortened, because it's also sloping down. That little length is why, I mean, this is what makes this one a more complicated object, is this really small detail here. And in this view, it's foreshortened, it's going down and away from me. In this view, it's going away from me and also kind of going down. And so it's compound foreshortened. Yeah, it's foreshortened in more than one direction. Here, only I guess in one direction. It's foreshortened down and away from me, but in the front view, it's like doubly foreshortened. I'm looking this way.
Foreshortened.
Yeah, I don't know if that's a true term I'm making.
Oh.
So don't write that one down.
Sure.
Yeah, a lot of stuff that I say you probably don't want to remember is true terminology. Sometimes, especially when I'm just winging my speech like that in my head. I will say things wrong, I guarantee it. But I need the counterbore details over here. But I think the object line work is kind of done. Yeah. Yeah, I think so. I'll still continue to use this grid to get the counterbore information. Stuff. I don't need to go down that far with those. I probably should have just been a little bit more aware that I really don't like this. This only goes down as deep as the counterbore, which is actually I've projected that over here. So really, I can do a little bit more a cleaner construction work here, so I keep track of it. But this one is only the depth of the counterbore, which starts in this surface and then goes down, and I'll just project over. Like I mean, some of these details, if you don't project, I understand. You could just draw them in that view. The value added in me in doing all this is that once I get to a 3D program or even 3D CAD here, I'll understand what it's doing. Essentially it's doing this kind of work for us. And this is an appreciation for how people would line draw for sure. They use their pencil drawers use this technique a lot. It saved them a lot of time rather than they wouldn't want to measure out each view. They would just use, it was quicker in pencil drawing because they could do vertical and horizontal lines so fast with the tooling they had set up on their drafting table, usually their incline drafting table where they've got the T-square like always locked in as a horizontal line drawer. And they have different triangles they would throw in on the top of the T-square to make 90-degree angles or 30, 60, 90s. And they'd have an array of triangles. So they were just really quick to use projection to keep themselves from having to measure out each view. Like you could argue in CAD, it's just easier to go over that other view and just measure it all out. And I don't disagree with that. Yeah. So it's kind of a throwback technique, and it is. I do feel like it actually is maybe quicker than me making another error here. If I've been careful in inputting my data, then projecting to me is quicker than having to be careful in putting in my data over here. So I don't know. So the moral of the story is I believe in orthographic projection. I am a believer. I do believe that it does help. And it's a real visualization of what these 3D programs are going to do instantaneously for us. But we'll have this concept really built in our mind that this is what's going on. I think that's the counter bore through, and that's just center line. So I think I'm going to turn off my structure layer and go to center line work, but I think that's what that's going to look like. And if I miss something, I'll try to find it, but I'm going to do center line stuff now. Oh, center mark has to go there. Let's not forget that. These are 6 millimeters. This is a metric template. 6 millimeters is roughly the equivalent of 0.375. That's cool. Some center lines, maybe. Sure, this one. This one here. Let's repeat that. I'm just gonna only extend this through where it goes, right? It was just based off the length of the lines that I selected. So, and then I still need to change the extension to 6. Just match properties. Yeah, I like that as a good start. I can maybe refine those later if I find that I don't like this like total alignment there. That's okay. Just leave it for a minute. So then if I reanalyze, if I'm going to start dimensioning this thing out, so I kind of think of, I don't know, I've told you that when, well, I mean, this is a uniform piece. I do feel like this is something that's been machined or is 3D printed. And so like the auxiliary support that we drew yesterday, I kind of almost view that as like almost like 3 different parts. And so the way I start to dimension them is I kind of evaluate each of those parts kind of independently for size and location, overalls of those parts, and then size and location of any of the features that are in this, any features of size. That's what I call like a hole, or I call like notches, or maybe I call them features of size. They have like, I think of this counter bore as a feature of size on this part. And I even think of like some of the inclined and turning surfaces as features of size, of some sort of size. So this one I just start evaluating like all the surfaces, really. I look at the independent surfaces and I feel like, do I need to dimension them all out? And if I start to analyze that, I'll recognize obviously that I have a foreshortened surface, and never do I have this surface that I can fully dimension its features of its size and its features in any of these views. Yeah, yes, here I can get, technically this is a true length, so I could get 1 dimension there. If I'm just evaluating this surface, I can get 1 dimension here, and I've been able to figure out what that measurement is. This is actually a true length now to there. Like the surface is going away from me here. It appears as an edge, and so it's totally, this is something that's dimensionable now. It wasn't given to me now, so I feel like I should add it to my dimensions when I go to dimension. And I'll even be able to get this particular line, except for I just know that I can't get that. So really, and this is not the true length either. I'm thinking of that, how far this bottom edge of that goes, this particular surface. But I am able to get it up here, right? Like this is a true length, like where it turns from here, at least if I'm thinking of the bottom of it, right? Remember, if I'm looking at this edge, it's a surface, so it has kind of a top edge and a bottom edge. The bottom edge is a true length, clear over to there, kind of like it looks here. And so but the top edge is not, because the top edge, while it is in an alignment, and when I'm looking down on it, the bottom and the top edge of that surface are totally parallel with each other and perpendicular to my line of sight where they line up. But the top edge is got some true length like this. Then once it hits this point, it falls down and away from me. And so it's kind of like the top edge is not totally measurable or dimensionable. So the only thing that makes, so I feel like if I just analyze, if I go back to the surface, I'm really like beating it to death. I understand. I'm just going to go around and say, yep, true length, not true length here, but here across the bottom. Okay. Then I go up this side. Yep, true length, not true length here, and not true length here. And then I get back to this area where it's not true length here, but it's true length here. So that's kind of how I'm evaluating the side. And what I recognize if I do that is like, oh, that stupid little corner that's like notched looking in that front view. It's going to need an auxiliary view to pull out to detail it. There's I mean, it's arguable they could be like, well, if I just give them point to point lineup, will that be dimensionable enough? And I think that, yes, you could. Like, where I wasn't given it in my isometric drawing, I could probably give them point to point and then have them like figure out and maybe make a note that says, hey, this length is unknown on my drawing, but you should be able to figure it out point to point. I mean, that's a weird local note, but I couldn't say that wouldn't be wrong, because I feel like to recognize that is needing an auxiliary view is maybe difficult to see. But let me evaluate the other surface that's inclined here, and that's what you'll notice about auxiliary views. They tend to be these inclined surfaces, right? Like anything that's perpendicular, straight up and down, from top, fronts, and right sides are going to be dimensionable. But when we get into these inclined surfaces, we got to take a harder look at them. So now I'm going to look at this. So that I've already evaluated. There's an issue on this little point. Now let me look at, it kind of shares. It's going to share the same issue with this surface. What I'm telling you, because when I look at this surface now to see like, do I have its true length dimensionable in at least somewhere on my views? So I'll just evaluate it like all the way around its perimeter and just try to make sense of it. So I'm looking at this surface. I'm thinking, well, top down, yes. I know this whole surface is sloped down and away from me, but when I see it here, this is a true length line. So no matter how far it slopes down to there, once it stops, I will able to pull this actual true dimension in the top view or in the bottom view. Only it's a hidden view or in the front view. The only reason why I wouldn't want to dimension here is it's a hidden view here, but I actually have it as a visible line here. So that's good. That's true length. What about this side? I'm just going to go around it clockwise. No, this side, no. This is sloped down and away from me. So then I'm going to look at my other views and decide if could I dimension them over there. Yeah, actually, that edge I could in the right side view. It's sloped here, but this is like the surface is totally perpendicular to my line of sight. So I get the lineup of this surface from kind of right side to left side, totally as an edge here. Look, and so the right side I can definitely see as a true length line right there. So I could dimension this. I could do it an aligned dimension, but probably I wouldn't do that. I'd probably do like a point to point, dimension like vertically and horizontally, point to point to define that true length in the right side view. So I feel good about those two sides. I come to the top, this side here, and I'm like, well, yeah, this is the top surface that my eyeballs are perpendicular to. So this is a true length line, at least until it hits here. So this line is a true length in my top view. And it's the only view where, well, it actually shows up in my front view too. It's like true length, at least to that point. And then it turns and goes away. So then I get into that same flipping little weird corner where at this point, this is going down and away from me. If I'm just looking at it in relationship to this surface. And also I found that out here that it's going, it looks like it's going down here, but remember, it's also going away from you here. So that's that compound foreshortened. It's probably not a true term, but it's what makes sense to me. So this impacts both of those inclines. Well, this inclined surface and this one up and down. This issue here it impacts both of these. So what it makes me think about doing is pulling an auxiliary view for this one, potentially, and pulling an auxiliary view for this surface here. And then what I'm going to determine is that I've got to determine where to pull my auxiliary views from. So a lot of times and that's one that we recognize as I felt like was an inaccurate question in chapter 9 question set was I look to pull the auxiliary view where those surfaces appear as an edge. And because then I'm going to pull like a projection plane from an edge of those surfaces. And I have a few, so that means I have a few options to choose from. So maybe I'll just look at this surface first and figure out where to pull the auxiliary view on it. And so if I pull it here, I'm dealing with foreshortened surface. So I don't think I'm gonna, and so this is where the surface appears as a surface. So I'm gonna like not pull it from this view at all. Then I'm gonna go over and maybe look at this view here. Well, it actually appears as a foreshortened surface here as well, and it's also hidden in my view here. I mean, from this point to this point is that surface that I'm seeing here. It's just even more severely foreshortened. Let's see. So then I come up here and I say, hey, this is that surface appearing as an edge. And that's so this is where I'm going to pull that. I'm going to pull this auxiliary view from this edge here. And I'm going to build this little angle part that is going to hopefully allow me to like detail all the dimensions all the way around its perimeter as true lengths. So then I have to decide, okay, so I think I've identified the view where this particular auxiliary view is going to come from. Let me decide if I'm going to pull it up this way or if I'm going to pull it this way. I feel like I could go either direction. Like I don't think I think there's good. There like one might be better or best. It depends on how I'm going to. Obviously, it might be harder to pull it this way if I've got a bunch of dimensions going on. I'm just worried about viewports or whatever. But um, um, maybe what I'm going to do is I might just make a copy of my top view and just move it up and out of the way. And I might just make I'm gonna plan on making a viewport maybe that will hold the top view and that auxiliary view of that surface. And just so I don't have to worry about it crashing into something, because I might hopefully have like a viewport scoped in on this one here. And so if I put a bunch of stuff, if I pull an auxiliary view over here and detail it maybe out here, it might crunch in and be hard to like not interfere with some dimensioning on this view here, especially because I'm probably going to try to dimension here in between views. So I'm going to keep this as a viewport probably, and then I'm going to move this up and out of the way. I mean, you could argue that, well, why don't I go the other way then? I'm like, yeah, we probably could. I mean, we could probably leave this thing and pull it over here and put it up and out of the way here. So I don't think that's wrong. Yeah, I don't know. I think I've done it that way before, but for whatever reason, I'm looking at this thinking, well, if I'm gonna, that's me kind of looking at that view as I pull it like through some of the material. I don't know. Like it looks cleaner to me to pull the auxiliary view down in a way where I'm not going over like a lot. But there is no right or wrong here. I just got to remember what it's going to look like if I'm pulling that view. And so I think about like folding up, like making a box out of like if I'm going to fold this with paper. And so I don't know, like it does. I don't know. I'll think about that one. Go ahead, Riley. What do you think?
So two symmetrical surfaces, why do you choose one over the other?
Why would I choose one? I've got to do both, actually.
Oh, you have to do both.
I'm going to do both. Yeah, it's just that I'm only looking at. I'm just kind of trying to figure out. So I've only really evaluated this surface, and I've determined I'm going to pull it off the top view. And so I haven't even thought about this one yet. But I'm not going to pull. I can tell now I'm not going to pull it. So this inclined surface for its auxiliary view, I'm not going to pull it from this view because it appears as a surface here and it's foreshortened. So now I'm going to come down to this one and say, here that surface appears as an edge. And so this to me is probably where I'm going to pull my my other surface auxiliary view. However, can I pull it over here? No, because that surface, well, maybe I could pull it from here. Not really. No, that appears as a surface, right? Sorry, this hidden line here is that back surface. And so I'm not going to pull it here either. So I feel like I'm going to pull the issues that I have with this surface, I'm going to pull an auxiliary view off the right side. And the issues that I have with this surface, I'm going to pull them off the top view. So I am going to do two auxiliary views here. And it's because those surfaces share the issue that I have on that compound little portion. The surfaces share that relationship. And so they're both going to be affected by that problem that I have. And they're going to need to be defined. Yeah. At least for our practice, just to practice with auxiliary views. I do kind of argue I haven't thought through that. It just dawned on me today where I'm saying, well, could I just dimension what I know? And could that be enough information for someone like a machinist to figure out? Yes, probably, but I'd be leaving them some work to do. And they might want an auxiliary view just to even though they could maybe figure it out, they would like to probably have on their drawing, like some reference to, even if your auxiliary view was just carrying reference dimensions for them, and you were holding them to the true lengths that I really can define in these three views, I would say, hey, these are all my like control dimensions. I'm gonna give you an auxiliary view with a couple of extra reference dimensions that if you have like a gray area, you can use them as a reference. So, yeah, anyway. Because it's only that little bit, I mean, there's my auxiliary view, what I really am gonna pull out of there is probably just a couple dimensions. And, so we'll see that when we get to it, but let's pull those views first. I mean, you could have gone to town dimensioning and then figured out that you need to pull the views, but yeah. And like I say, even here, I guess I'm just gonna pull it off of this and pull it this way when I get to that view. This is the one that I kind of have an option whether I go down and to the left or if I go up and to the right to pull the view. And I don't really think there's a good, better, or best here. I think I've pulled it up to the left, right before. So maybe now, because I've done that one that way, I'm gonna pull it down to the right. But because I don't know which one is potentially better. I just know that if I do pull this one this way, it's gonna interfere. So I'm gonna make a copy. And let's see if I can skip these ones. So I'm gonna make a copy of this. I don't want all the construction material, but I just want to move it in orthographic alignment here. I don't like to pull these crazy. I still like to keep them in alignment, just give myself some room to work with. And then this is going to become another viewport for me up here, probably. So, and I'm going to build a projection plane, which is kind of hard. We learned that last time, right? Like I like to offset, and this should work for me. I'm going to try to offset this line. Work from this line here. It's a one-piece line. That's good, even though it is technically two parts to it. But I'm going to look at the bottom edge of it because it's not got the problems going on with it, right? So I feel like I'm going to build my view kind of from the bottom edge of that surface starting. But I need to build a projection plane, and I think I'm just going to do it the way I did it last time. Just be kind of careful. So I don't know what this angle is. I don't know if it's going to match any angle grips that I have. That's why I like to use that offset command. So let's see. Yeah, I think so. We just need to offset at some distance. I don't know how far. How far is this? Measure a distance. I need to get it out here to clear something. It's not going to be at this angle necessarily, but I'm just looking. Oh, if I offset that line about 80 millimeters, that might be a good start to this. If I say offset 80, that. Planning on that being my bottom edge. I mean, this should be, I mean, sometimes I don't trust my CAD, but this should be parallel, right? Like if I take this, it should be 80 millimeters there from either end. 80 to 80. I mean, I should build a square projection plane. I think I do these. Sometimes I build a new layer for this kind of stuff. So I might just build a new layer.
Did you make a copy of that part you're projecting? What you did?
I did, yeah, I got those. Yeah, I kept, yeah, this is pretty common for me. Yep. I'm gonna keep the stuff that I've actually done all the work and construction work there. And then I just made a copy of it. Because I'll do another viewport of this. I might try to capture all this in one viewport, but we'll see. If I have to do another viewport of the auxiliary view, so be it. That is that. This should mean that construction here to turn that on. I hope that's the projection plane that I'm going to be able to build this little thing from. I mean, those should, I mean, that what I'm trying to build there is just a square box, right? Like just 90 degree, like so, okay, it's okay. I'm just doing a little angular, just do a little check to make sure I'm not going to start building from something that's out of square. It really should be kind of a square box, 90. So I'm going to consider this the bottom edge. It really is. It really is the bottom edge of that is the true length in here. It doesn't have anything that going on. So that is the actual length of the bottom edge. So I can just I can view that as my bottom edge, and then I view, so I feel like I'm gonna build my view this way out though, if that's my bottom edge, like, cause I do feel like if I just like, if I just took this, once I build it, and it's gonna look like just pretty much a little rectangular piece here. Once I build it, I just would slide it in along those projection planes and then attach it, and I would just fold it up to be the piece that's missing there, you know, to be that surface. I kind of view that's what I'm doing, so I view that this is my box. That's what I mean, like folding up a box or something. I'm just going to view myself when I would, if I, you know, if I needed to make this out of paper, I would draw it all out so it's the right size. Just slide that over, and then just fold it up or tape it in there, right? So I'm going to build it accordingly. So I don't think I would build this way with the top edge being over here, because that'd be where I'd slide it over, and then I have to like turn it, and so I kind of think of the projection plane of it, like I project it over the bottom, and then I'm going to build it out this way. Yeah, I think so. So maybe I'll just offset this one more time, is how I kind of did that last one. I'm gonna offset it what that height is. It is a height dimension that I'm looking for, which is in my this view right here, this true length height. So I'm gonna build this. Essentially, it's gonna look like this shape, but it's gonna be the actual true length of it. And so what is that height? I'll just look at it here to make sure I don't build it, but it's. Did I ever have this one coming down? I could measure it off I could just measure it over
It's
there. 15, 35, yep, and then yep, and then 15 and 20, yeah. 15, love it. So that's all that is. So I should be able to offset that 15 and still stay square. Offset this. 15 millimeters. Like that. And then we'll try to I'm gonna try to figure out what's missing here, but really that should go from here to here, and that should remain a square, right? That's just that. That's the side we knew. It's a true length right there. This one we don't know, but we can measure this here now. It wasn't given on our measurements, but we have it here now to measure. That is a true length from there to down. It's going to be the opposite side that I just drew from like from the bottom up, and then we'll have like a little miter in it. So let me measure what this measures here. And maybe I'll just, I don't know, I kind of want to keep it. So here's my calculator. If you don't ever use your calculator, you can use it. It has a point-to-point measurement here. And it's helpful to do this for math or whatever, but this point-to-point I kind of like in my calculator, because it'll bring back up my calculator. That's what that measures, 13.92. Sometimes I use this just as I could use this calculator too. Sometimes I just use my other calculator. But my calculators are on my taskbar on all my computers. All right. 13.92. So I feel like I should be able to measure that line along there, like 13.92. Whether or not I can pull that out and stay like there's nothing to like to trace along there. So I could draw a construction line, I guess. Is this and I should just check this myself. This remains 90 degrees. Just want to be careful. That should remain 90 degrees. And now along that line, maybe I should be able to do that 13.92 on a visible layer. I don't know if it will totally let me 13.92. This could be the problem. There's just nothing to snap into there, and to do this at 13.92 is where I want to go along this edge. I feel like this could be a problem unless I've got like something weird going on. That's what I want to know is 13.92. I know what I can do. Sure. Since there's nothing to track along there to make sure I stay perfectly in projection with that, I'll just offset this one 13.92, right? So I feel like I should be able to use offset 13.92, this thing like that. This is really just for construction work. So if I say I'm going to match these properties, And then this should measure 13.92, right? From this corner to that, it's 13.92. Yeah, that's how long that was. And I just need to, so that's kind of how far, so I can trace this now with visible line work. This should make it easier to trace. Like that. And then it's got some, and then this is the top edge. So I know I use it to offset it, but really it's going to be shorter. So let me see if I have that dimension. I don't know if it was expressly given here. It's this length, but I don't know, right? Oh wait, it's this length. This one right here. So I'll look to my views to see if I have what this is. So it wasn't given on that drawing. So I'm gonna look at what I've got here. And it's right here. It's actually given in my top view. Where it hits this one right there. So I'm gonna measure that. Maybe I'll just, I'll clear my calculator here. And I'll pick those 2 points because I don't know what that measurement is. I just know that it's true length, at least from here to here, and then it starts to go down and away from me. So that's that weird. And I might punch in this whole number. My calculator might be, I'm only drawing to 4 decimal places in accuracy. It's just that's the default accuracy that which we can change, but we haven't ever changed that. It's just default drawing to 4 decimal places. My dimensioning is held to 2 decimal places for the most part. And this particular thing kicked me out. This maybe the calculator, maybe this is the true length and this ends here. I will put in, I guess when I have a weird dimension like this, I might put in all of it. I mean, that's 1, 2, 3, 4, 5, 6, 7 decimal places. Okay, maybe that's a little overkill, 5 or 6, I don't know. If I have it, I might as well use it. If this went on forever, I might cut myself off at a decimal place beyond how far CADD is. So I'd probably go at least to 5 decimal places because then you'll let CADD round that 4th decimal place. That makes sense. This is how I think anyway. I overthink, right? That's okay. But what I'm saying is this particular line, maybe I'll just do this as a, I know what I'll do. I'm gonna change this to a construction line. And then I'm gonna trace over the top of this. Or maybe I'll just offset. That worked well for me the last time. So let me offset it the other direction. Offset this one, this particular line. 40.122. Yeah, 68.
Offset, you can specify the distance just how the same way you measure the distance.
You totally can.
Yes.
Yes.
That works too. You don't have that in numbers.
Totally. Yes. Yes. You could do, so if I wanted, yes. And I did that last time when I could pick offset. I could come down here and say offset how far? Well, I'm gonna offset from like here to here, right? And this is gonna input the offset distance. And then I'm gonna select this thing as the one to offset like that. Yeah, you're right. That's a great way. That is really handy. And then you don't fat finger the dimension wrong, right? Yes. That's good. Thanks. I do appreciate that. I think I talked through that last time, and that should go down to there, right? This I'm gonna do a little bit of cleanup here. This I can change to construction work. It was my offset lines. And then I'm gonna retrace this from my top edge. So what I've done now this is a true length. So that's what that measures. And so what I want to show you maybe is just that what does that measure from there to there? That measures, oh, it's adding or I'm doing something. Let me clear that out. This is the actual length of that unknown thing, 6.1145377.6. If I measured it here, it doesn't measure anywhere near that. So I'm just going to remember that 6.11, we'll say 6.11. Okay, let's do another quick measurement. That's only 5.3. That's how foreshortened that is. And right here, let's do a quick little measurement. So it's actually 611 in real. So let's see. What does it measure here? 60. This is close, but it's because of it's sloping a little bit down for me. 601. So this would technically be, this is not quite right. It's really severely foreshortened here and just slightly foreshortened in that view, but that's the true length, right? We just built it from point to point. So when I come, and I'll build the other one now, and then maybe I'll say it's part 2. Maybe I'll stop this recording. It'll be kind of long, but I think I'll build my other one before I stop, and then I'll go back to dimensioning. But I think what I'll do when I go to dimension this, I'm only going to use this. I'm only going to dimension the stuff that I really needed this view for, which is really that little piece there, right? So I feel like everywhere else I'll be able to actually dimension in my other views, and I think I will prefer to put the other dimensions in the other view because they'll be all aligned dimensions around here. Well, and so I'm only going to use what I need over there. So I think I'm just going to call this out as an aligned dimension, and potentially it could become a reference dimension. And I'd actually want to define that really more by the actual dimensions that I can put down on my other views, which are all of them. Like if I go back, I'll be like, there's one of the dimensions will go there. The other dimension may go here, probably here because there are visible lines. This dimension I'm going to do as a point to point rather than like an align dimension. I'll just do the point to point align dimensions there for that particular surface here, for this particular edge. And then this one here, and then the bottom edge I'll grab. Where am I going to grab the bottom edge? Well, it would have to be an aligned dimension. So there could be an argument that if I'm going to have one aligned dimension here, I might put the bottom edge as an aligned dimension down here as well. And so the moral of the story is I try to avoid aligned dimensions on my objects, unless there are reasons why I'll break that rule. I guess as a general rule, I'm going to do point to point, kind of XY coordinate type dimensioning on my main views that are in orthographic alignment. I'll break the rule a little bit for some aligned dimensions on my auxiliary view. However, I could rotate this to the X and Y, so it's like, straight up and down with X and Y, and then I could just do all the dimensions on it, but yeah. I think so. But I might determine that I wish this was all a little bit closer, but really I've left this so that I could dimension a little bit here and dimension a little bit here. Like that's what I mean. I was just trying to play, and that it's not an exact science, and so I may still have issues within a viewport or a scale size on my drawing. But I've got the piece that I could actually move and manipulate from now, and then I just need to do this one. So I'm gonna build the same kind of like I'm gonna offset this. Remember, this is a true length. It's just that it's the right side surface edge of this particular surface. So that this, where it's foreshortened here, is true length in right side. And so I'm going to offset this line and build my view. I'm going to offset it how far? At first, I'm going to offset it just far enough to be away from my object and allow myself to dimension. Because I feel like another viewport might be right here and capture what I've got going on with this other auxiliary view. So I don't know, when I get to my drawing, I might need to do a removed auxiliary view and just make sure I keep track of it and label it if I do that. So let's do an offset of some unknown distance. Maybe not quite as far. I went 80 on this one because I just needed to clear this corner, but for this one, I just need to leave enough room for a few dimensions. So it's just kind of I'm just getting an idea of how far out. Oh, my dimensions probably, maybe I'll offset this like 30 millimeters. That'll give me some room to do some dimensioning. And I'll put this thing way out here if I'm trying to capture it in the same viewport. Let's do that. I'm going to offset 30. Sure, 30 is some unknown. That's a great place to start. I view that piece though as the right side surface edge, essentially the edge that I just offset. I view that as that edge actually. And so when I build this, I'm going to build it out here. And I'm going to feel like I'm going to slide it back over to just fold it down to be the surface that I'm going to create here. So it's kind of like on paper, it's like origami a little bit. Yeah. Especially if this was a hollow piece and I did have to make each side surface independently, if it wasn't going to be a machine thing, it actually was just surfaces that are all hooked together or welded together. It's a hollow box. Well, then this is one reason why I have to do what I'm doing is to be able to define that edge and have a laser cut it or something. So now this is actually, a 2D profile of that, and a laser could cut this out its actual size. So yeah, maybe this thing's really big. It's gigantic and it's all hollow. Okay. I'll keep this on construction layer too, though. That works good. It's my auxiliary construction layer. It's technically when I come out from there to there, and from here to this point to point, this should be creating 90 degrees. I just double check this to make sure I didn't pull something weird out of alignment. Because the idea is I'm just building a perpendicular to that surface projection plane. So that's good. I think that checks out good. Now I do want to offset this again. It's actual distance. So its actual distance is here. This is a true length. It was also given here, I think it's 50. The overall thing, so I've already drawn this edge, and I'm gonna draw, 50, draw this edge, which I'm gonna have to customize a little bit. Offset again. Put these together. This edge is the back edge there. That's that one, it's true length. Then this edge comes to some point and cuts down. So I'll see if I've got that data, right? Like, it's the same length. It's this length right here is how far I need to go this way. I think I'll do an offset of that length, right? And I'll do it this. So I'll use an offset. How far? I'm gonna offset this far. To right here. Be careful. I'm gonna pull the right point for that one. I'm gonna offset this object. It's construction line work though. I'm just gonna change that real quick to construction. So this one was just to get that distance over. Now I'm gonna draw my line here. Right, this is the actual object that goes over to there. I'm hoping that still says that it's square. If not, then I've got issues in how my offset fold. It's still okay. Okay, and then it comes down from there, down to some distance, which I think I probably have right here, maybe this distance. And this distance they should be the same distances, right? So I'll pull those as an am I gonna offset that? Yeah, I'm gonna offset that. Maybe this line here, I'll offset it. So distance is this. It's here. I'll just make sure that was not. That's just some construction work for me for my part. I offset that correct? I don't think I offsetted that correct. Hold on. Let me just stop. So this distance from here to here is the offset distance. This is actually true length until it hits that point, and then it's doing something weird across here. So I think I'm going to say this distance is my offset distance of this line. That looks way better to me. Just tell it didn't proportionally look correct. And then should I be able to? And then I should be able to connect point to point. And look at that, it's 611. That sounds correct to me. Like building these independently, they should be the same length actually. They might be decimally a little bit wrong because there is some human error here, point to point error. But I'm going to measure this distance. Sorry, I'll put my calculator in and maybe I like it. Sorry, I need to clear my calculator. Clear it. That was point. What is this measure? 6.11453776. Okay, that's pretty cool. Wait, I'm gonna take a screenshot. I think I'm almost exact, am I? I'm gonna take a screenshot of this because I'm gonna move it over here. I clear this and pull that dimension again. And the calculator, these should line up, right? These should be the same. They're gonna match up. I have 6.11453.7. I have it exactly out to that many decimal places. Even just drawing line to line, point to point. Like I thought I might have a little error in some decimal, especially if I'm in within 2 or 3 decimals. If I'm having errors, it's not great. It does show the inaccuracy of how I drew, but technically I've nailed them both. Nailed it. I'm gonna end this video before I start dimensioning. I'm gonna hope that I hit record.